May-June 2016, variant 3.3. It's an acid-base titration with a prior dilution of Fa2 hydrochloric acid. The question says you will determine the concentration of a solution of hydrochloric acid by diluting it and then titrating the diluted solution against an alkali. Acid with an alkali. Fa1 was made by dissolving 1.06 grams of sodium hydroxide in distilled water to make 250 centimeter cube of solution. Fa2 is hydrochloric acid. In this case, the indicator provided is bromophenol blue indicator. Apparatus and chemicals given for this question includes a burette, 2 volumetric pipette of volume 25 centimeter cube, a pipette filler, conical flask with a funnel, white tile and a retort stand, along with a volumetric flask of capacity 250 centimeter cube. 2 chemicals, Fa1 and Fa2, and indicator bromophenol blue with a dropping pipette. Method says pipette 25 centimeter cube of Fa2 into 250 centimeter cube volumetric flask. Keep remaining Fa2 for use in question number 2. That is the next question in this paper. Add distilled water to make 250 centimeter cube of solution and shake the flask thoroughly. Label this solution Fa3. So this Fa2 is pipetted out 25 and by using volumetric flask it is made up to 250. So this is what we call 10 times dilution. So 25 centimeter cube is made by adding water up to 250 centimeter cube. Now let's prepare this solution and see how volumetric flask is used. Now using pipette, let us take 25 centimeter cube of this Fa2. Pipette has 2 ends. One is broader end and the other is narrow end. So this narrow end is the lower side and this is the upper side. There is a mark here which says that you have to take up till this mark so that it will be 25 centimeter cube in exact. So first of all, for that we need to attach a pipette filler, and this is the pipette filler. Attach this pipette filler so strongly that it will hold the pipette by itself. Now this pipette bulb has 3 buttons. Number 1, A. When you press this A and squeeze this bulb, it will remain deflated. Then it has S button here. S button means suction. So when you put this in any solution and press this S button, it will start sucking up the solution. This E button stands for ejection of the liquid. When you have filled anything and you want to eject that liquid out, press this E button. So now let's press this S button and fill the liquid up till the mark. So as soon as you fill the liquid up to the mark, and remember, every time you have to take the lower meniscus. Now you can see I have taken the liquid up till the mark. Let me transfer this into this volumetric flask. 250 centimeter cube volumetric flask given. So let's transfer our solution in this. By pressing this E button, or you can remove the pipette filler, again the same thing, the liquid will drain out. Now, this volumetric flask needs to be filled up till this mark. Here you can see there is a mark. Up till here, the volume becomes 250 in exact. So for that, you need to fill this volumetric flask with distilled water. So let's take distilled water here. So we need a larger volume. That is why I will remove the cap and I will add quite faster first. And when I reach close to the mark, I will attach this cap and I will add dropwise. Now, I will put it back and remove this funnel, and a care needs to be taken while filling this using this bottle. Why? Because you cannot move your liquid more than this mark. Why? Because the dilution will be disturbed and you cannot discard once it goes up. So a care needs to be taken that you have to fill up till this mark and that's it. You cannot go above this mark. So let me squeeze the bottle and start filling gradually. And now you can see I have taken up till the mark only. Now you have to put a cap over this and hold this with your thumb and invert this at least 3 times so that the solution is mixed. We call it shake well. And this solution which is prepared now is your Fa3, as the question has said, label this as Fa3. So the solution is labeled Fa3. After labeling Fa3, the third point in the method says fill the burette with Fa3. Now fill the burette with Fa3. To fill the burette, we need to close this knob first clockwise, and then using this funnel we will start pouring in Fa3. So here is Fa3. Now have a look at this lower end. There is a volume in this burette which is below this knob, and this needs to be filled also. Therefore we will open this knob in the solution so that the solution will drain out and then close. And now you can see this column is filled. Actually this includes in the volume we have filled here. So it's necessary to fill this column also. Now let's make the mark up till the 0. So here is our 0 mark. We need to fill here up till 0. So let me continue adding the solution up till 0 mark. Now, when the solution goes up more than 0, Here you can see it's more than 0. So what we need to do is we need to remove. Now, if you see closely, I have filled it up till the 0 mark only. So this reading is taken as 0. Now place this burette in the retort stand. The level of this burette should be 2 to 3 inches above this flask. So here you have a space of 2 to 3 inches so that you can add, you can swirl easily. Next point in the method says use the second pipette to transfer 25 centimeter cube of Fa1 into the conical flask. Add about 10 drops of bromophenol blue indicator. Using second pipette means this pipette which was used before should not be used anymore because the solution was filled in this already. So we will use another pipette. We will attach this pipette filler here, and then we will take 25 centimeter cube of Fa1. So here is our Fa1, 25 centimeter cube up till the mark. And transfer this into the conical flask. Now add 10 drops of bromophenol blue indicator as they have said. So this is our bromophenol blue indicator. Let's add 10 drops here. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the solution has turned completely blue. It's a dark blue solution. The next step says perform a rough titration and record your burette readings in the space below. The end point is reached when the solution becomes a permanent yellow color. This is our initial burette reading, 0.00. Now using your one hand on the knob and the other hand on this conical flask, we will swirl it continuously and we will add this solution Fa3 filled in the burette until the solution goes yellow. So I have opened the tab. Now the solution is going a bit lighter and the solution has turned completely yellow. So this is the end point in rough titration. So this is the final burette reading, 30.70. So I have recorded the initial burette reading as 0.00 centimeter cube because every burette reading has to be 2 dp. Final burette reading as 30.70, so the rough titer used is 30.70 centimeter cube. Remember, do not just write here one value because in your mind you have initial as 0 already, so students directly write here 30.70. Instead, if you read this point, they have said record your burette readings. It means both the readings of rough titer, initial and final, must be recorded. Now let's move on to the next part where it says carry out as many accurate titrations as you think necessary to obtain a consistent results. Now what is meant by this term consistent results? Consistent results means when you repeat the experiment, you will ideally get the same titer value. Other than this rough titer, if you repeat the experiment, whatever the value you are getting, you must get that value again and again. The same value must be there. But if any deviation is happening, like more or less volume is used up in different titration results, so the consistent result means not more than, means less than or equals to 0.10 centimeter cube. If your two values lie within this range, that are assumed as consistent results. Therefore, they have asked you carry out as many accurate titrations you think necessary to obtain consistent results. Now the next, they say, make certain any recorded results show the precision of your practical work. As I have just explained, the results must be precise, means when you repeat them, you will get the same results. Record in a suitable form below all of your Burette readings and the volume of Fe3 added in each accurate titration. So in the space they have given here, we have to draw a suitable form. Suitable form means a comprehensive table that includes our accurate titration results. So let us draw this table first. So I have made here a comprehensive table including all the necessary readings. However, I have kept this third titration results open. Why? Because if I get two results accurate in first two times, I do not need to perform the third one. Therefore, this needs to be open. Whenever you need, you can do this. Now let's start performing our accurate titrations. Now before we start the accurate titration, let me refill the Burette, as it was used more than 30 cm cube. So let me refill this Burette with Fa3 solution made, and remember to mix the solution before you use it. Now once we are doing accurate titrations, we do not necessarily need the initial reading at 0. It could be any reading lesser than 5, 4, 3, something like this. So I have taken here lesser than 1 this time. I will record the initial Burette reading. The second thing to do here is empty and rinse this conical flask, which is used once. So we can rinse it with the tap water. Dry as much as you can, and then using the pipette same, take out Fa1 25 centimeter cube. Remember, use the same pipette you have used in the previous time, because two pipettes are given, so students get confused. So this is 25 centimeter cube in exact, transferred into the conical flask. Again, the 10 drops of bromophenol blue indicator. So here is our bromophenol blue indicator, 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Normally we add 3 drops, but whenever the question says this much to be added, then you have to add the same amount. Now let's record the initial Burette reading. This is our initial Burette reading, 0.80. Let's continue our accurate titration, but what is meant by the term accurate titration? It means when you are near the end point, like the previous rough titer result, you will slow down this volume addition from the Burette to dropwise, so that as soon as the color changes, you will stop the solution from the Burette. That is the accurate titration. So let me show you how. So first of all, I am adding a bit faster. as soon as solution turns lighter, I will stop it to dropwise. You can also take the volume according to your previous titration results. Now I have slowed down because it's getting lighter, and dropwise you can see you will keep swirling continuously, and as soon as the solution turns yellow, and here you go. So I have stopped as soon as solution turned yellow. So this is my accurate titration performed. This is the final Burette reading, 30.30. So I have recorded here the initial and final Burette readings for the first experiment. I will subtract these two values to get the volume of Fa3 used. So this is my volume used. Let me repeat the experiment one more time and see what are the accurate titration results coming. Now when I have repeated the experiment, I got in the second time these initial and final Burette readings, so the volume used is here. In this case now I do not need to repeat the experiment for the third time because the two values I got for the titer are not more than 0.1 apart. So I reached to the level of consistency. Now I will tick these two results that they are good enough. If not, then I would have performed it for the third time, and then I have ticked which two values here are 0.1 maximum apart from each other. Now let me tell you about these 7 marks here in this part A. Where are those 7 marks? Number 1, this first mark is for the initial Burette and final Burette readings for rough titration. So this 2 by 2 column here, it presents this first mark. The second mark is for the correct titles, final Burette readings, their units, initial Burette readings, volume used, here also. So the correct labels and the units account for the second mark. The third mark is for the readings of Burette recorded up to 2 decimal places. So here are all values recorded up to 2 decimal places. Even if it is 0, then I have written 0.00 because it's necessary. So the third mark is for 2 decimal places Burette readings. The fourth mark is for consistency in your work. So I have got 2 consistent results, therefore this mark is also awarded this way. Now the 3 marks are from supervisor's result. We look at the supervisor's result. If your accurate titration results are within 0.2 centimeter cube from the supervisor result, you will get all 3 marks. But if your value goes beyond 0.2, it could be plus minus both. If your value goes beyond 0.2 but still within 0.4, you will get 2 marks. 1 mark is deducted. And if your value goes more than 0.4, like up till 0.6, you will just get 1 mark of accuracy. And if your results are more than 0.6 apart from the supervisor result, you will not get any of these 3 marks. So this is how the 7 marks are allocated normally in the titration. Now let's move on to the next part, which says from your accurate titration results, obtain a suitable value for the volume of Fa3 to be used in your calculations. Show clearly how you obtained this value. Now, the 2 readings we got here are 29.4 and 29.50. So the average is obviously simply 29.45. But if you write just this, you will not get this mark. Why? Because They have said here, show clearly how you obtained this value. Therefore, you need to show here that you have added these two values, 29.50 and 29.40, and then you have divided by 2 to get the average results. So here you will get the mark for this part. Now, let's move on to the next part. Calculations. Show your working and appropriate significant figures in the final answer to each step of your calculations. So, appropriate significant figures means 3 significant figures minimum, or for better calculation, 4 significant figures. Calculate the concentration in moles per dm cube of sodium hydroxide in Fa1. So to calculate the concentration, we have studied a formula. Concentration is equals to amount in moles divided by the volume in decimeter cube. Since the unit they have asked here is moles per dm cube. To calculate the moles of sodium hydroxide in Fa1, let's look back on the previous page where they have said Fa1 was made by dissolving 1.06 grams of sodium hydroxide in distilled water to make 250 centimeter cube of solution. Therefore, the volume given is 250 centimeter cube and the mass in gram given is 1.06 grams. So, from the mass in gram, what we can do to calculate moles, we can divide by its MR. So 1.06 grams divided by the MR of sodium hydroxide, which can be calculated from the periodic table. And periodic table has sodium as 23.0, oxygen as 16.0, and hydrogen as 1.0. So if we calculate the moles of sodium hydroxide, we need to divide it by 40 mR of sodium hydroxide divided by the volume, which we have just seen that it was 250 centimeter cube. Now, if it is in centimeter cube, we need to divide it by 1000 to make it in decimeter cube according to the question. Moles per dm cube must be the concentration then. Now, if we calculate the answer for this part, the answer is 0.106 moles per dm cube concentration. The next part says, calculate the number of moles of sodium hydroxide present in 25 centimeter cube of Fa1. So if we have calculated the concentration, which is 0.106, and we need to calculate the moles in 25 centimeter cube of it, we can use the same formula. We can put the concentration here as 0.106 moles per dm cube is equals to the number of moles needs to be calculated divided by the volume we have taken here to 25 centimeter cube. So this is centimeter cube again divided by 1000 to make it in decimeter cube. Now, if we calculate the moles here, they are 0.00265. So these are the number of moles of sodium hydroxide in this 25 centimeter cube of Fa1. Now, the next part says, deduce the number of moles of hydrochloric acid present in the volume of Fa3 you have calculated in B. So the number of moles we have calculated are in 25 centimeter cube, and the volume of hydrochloric acid we have calculated in the part B, which is here in the part B, the volume calculated as there. So 25 of Fa1 has neutralized 29.45 of Fa3. Neutralized means according to the equation they have reacted in this ratio of 1:1. Therefore, the moles we have calculated for sodium hydroxide in the last part will go 1:1 with hydrochloric acid. Therefore, here what we can see HCl reacted with sodium hydroxide in 1:1 ratio. So the moles of sodium hydroxide we got in the previous part must have reacted with how much moles of hydrochloric acid? So the value must be the same, 0.00265 moles of acid must be consumed. Now this is the number of moles of acid present in the volume of Fa3 calculated in B, which means in the part B we have seen the volume was 29.45. It means this moles are present in 29.45 centimeter cube. Now let's move on to the next part in the calculation, which says calculate the concentration in moles per dm cube of hydrochloric acid in Fa2. Now this moles of hydrochloric acid we have calculated in this volume is actually Fa3, not Fa2. So first of all, calculate the concentration of this hydrochloric acid according to this moles and volume in Fa3. So the concentration of hydrochloric acid in Fa3 can be calculated as concentration is equals to moles, which are 0.00265, divided by the volume we have taken 29.45 from the part B to divide by 1000 to make it in decimeter cube. Now in this calculation, the answer of this is 0.08998. So this is approximately 0.0900 moles per dm cube. So this is the concentration of HCl in Fa3 we have calculated. Now, how to calculate the concentration of HCl in Fa2 from this Fa3? Now, let's look back in the previous part. This is a case of dilution. Here they have said also that hydrochloric acid is used after titrating. You can see from here the concentration of hydrochloric acid by diluting it, then titrating. It means we have the diluted concentration. Now, what is the original concentration? Just have a look here. Pipette 25 of Fa2 to 250 centimeter cube volumetric flask, and after making the solution with water, the solution was labeled as Fa3. So from here we can see that our Fa2 was taken as 25 centimeter cube. So 25 centimeter cube of Fa2 was diluted to form 250 centimeter cube diluted solution of Fa3. So this was the case of dilution, which means almost 10 times you have diluted your original Fa2. So here we have calculated the concentration, which is 0.09, and if we go back the 10 times dilution, what formula we can use here is C1V1 is equals to C2V2, where C1 is the concentration of Fa2 in moles per dm cube, multiply by the volume of Fa2 we have used 25 centimeter cube, is equals to, this is the concentration and volume of Fa3. So the concentration of Fa3 we have calculated is 0.09 moles per dm cube, and the volume we have made for this solution was actually 250. So 250 cm cube is the solution rate. So this C1V1 is equals to C2V2 is the equation we can use for dilution when we are calculating anything related to dilution. Now here the centimeter cube will be cancelled out with centimeter cube. So we will get the concentration in moles per dm cube directly. So if we calculate this 0.0900 multiplied by 250 upon 25, so the answer will be 0.900. Therefore, the concentration of Fa2 was 0.900. So this is the calculation of dilution with the titration involved. So here we comes to an end of 13 marks. So this was the acid-base titration involving dilution and the 13 marks question from May-June 16 variant 3.3.